Okay, we're back. Sorry about the power issue. Let's see if we can get a compilation. And so now he's giving me a hard time about n. N is not defined. Alright, let's do that. How does this work? Oh, right, math.pi is not defined either. Double D-O-O-U-B-L-E pi equals 3.14159265358 That's enough, right? And now n is an integer n, and that's equal to like 8. And now let's see if that makes the compiler a little happier. He's unhappy with this. Math was not declared. Yes. Math is not declared. Yeah, this porting is not going to work very easily if I keep just pasting in the Java. Now what's his problem? What's his problem? Is that too many digits? Is that his issue? Unqualified unique ID before numeric constant. What? What? What if I said pi was equal to 3? Would he like that better? What do you suppose is the problem here? Is it possible that it shouldn't be set at all? I'm really confused by this. Oh, do you suppose pi is already established as... Yeah, look, I was overwriting a known constant, pi. So pi is already known to the Arduino. Ooh. So if that's the case, it should be possible for me to print it, right? Serial.println, quote, pi. Yes, you can't override constants without getting those cryptic idiot errors. That makes perfect sense. So if I go to the serial monitor, what could it say? Pi 3.14, and that's it. That's pi. And if you don't like that value for pi, too bad, because that's it. Pi is 3. Got a problem with that? It's 3. Like, really? 3.14, that's it? I'm sitting here typing out pi to like 9, 10 digits, and this thing says pi is 3.14? I feel cheated. That's good enough for you. I don't understand how pi can be 3.14. What kind of compiler is this anyway? Alright. It's an Arduino compiler. That's what kind of compiler it is. And if you don't like that, we feel bad for you. So here's my little for loop, and I'm kind of thinking maybe if I just paste it in, math.cosine is not going to do me any good, right? There's got to be something wrong with what I'm about to do. All kinds of wrong. But I'm going to do it anyway because what the heck? And here it is. We're going to go into this loop, and let's forget for a moment about print high and... Oh, I guess we better do it in the setup, right? Oh no, it's got to be part of the loop because it's going to be done regularly. Okay. Just for now, I'm liking the idea of making a subroutine, but I'm not sure that I can, so I'm just going to skip the subroutine part and put it into the setup, and I'm going to hit paste. Now I know that's all kinds of wrong. Okay, math.cosine, that ain't going to work. Whoops. Math.sine, that ain't going to work. What are we using for input ij? That's just our ramp, right? Dare I copy the data over? No, I'll just use ramp. And here we'll just use the data for the ramp. And what else do you got? What else did I do wrong in all of this? I'm sure this is all kinds of wrong, okay? This J is defined all right? That's all right. 2 pi ijk, has that been defined? ijk on n, yep. How about this R data and I data? I guess that's okay. What else? Well, let's let the compiler tell us what else is wrong. Ha! Are you guys as astounded by this as I am? Wow. Wow. Now, having done this, I should, in theory, be able to get the power spectral density. Now, the power spectral density is going to go into an array whose size is equal to 8. So what I will do is I will take this little silly foo variable, make it a double, call it PSD, give it size 8. Now, is that going to get me in some kind of trouble later because I used foo? Yes. So I dare not use the print h here, or the or any of this other junk. Let's see. So we're fine now because this foo is local in its name. So I've got a DFT being computed on the ramp. I've got a power spectral density array which is global and available to me. I've got a setup in here which can do the PSD computation. So let's do that. For integer I equals 0 while I is less than n, I guess it's capital N, isn't it? I plus plus, and how shall we do the PSD computation? PSD of I equals R data of K. How does one oh, I guess you need I, right? How do you normally square things in C? Yeah, that's how I do it. R data of I, and oh, and then you have to add that for the imaginary data too. I data of I times I data of I, so that's squared. Shall we normalize it while we're at it? Because if we're going to normalize it, then we have to take the whole thing and divide through by n. Or not. And now I think maybe we can write a print statement. How about a print statement that prints all the elements in a double precision array? So we'll get rid of this print high thing and we'll call this print array, and we'll pass in a double precision array and its length. So double data array, and the size of the array integer n maybe. And now what we can do is for k equals 0 while k is less than n, k plus plus d of k gets printed. So this will print an array. What do you think of that? An arbitrary array of size n. Let's just make sure that I haven't made any mistakes. He's unhappy here. What did I do wrong? Oh, got too many R's here? Thank you. Let's see what else I did wrong. Huh. He likes it. That's not too bad. So now, in my setup, I could probably call print array of PSD and pass in n. I don't know, does that work? I suppose I could see if the compiler complains about it. Compiler likes it. Therefore it must work. No need to test it, right? Says, you guys are not at least skeptical? I think I should test it. Don't you think so? No, Professor Lyon, you should test it. Okay, I will. Glad you asked. Let's see if any of this works. Oh, I guess I gotta look at the output, right? Serial monitor. Shoot. Does that look even remotely right? Oh, you know what I didn't do is I didn't compare it against the Java code. Now, let's see. The Java code does a normalize data. Normalize data. Oh, you normalize the data by dividing through by n first. Then you proceed to print the power spectral density. So I got this a little bit backwards. Let's grab this code for normalizing data. Let's put it into the Arduino. Paste. Normalize data. Now normalize data tries to obtain n by calling rdata.length, but you can't do that in C. But n is still correct. I think this will still compile. Oh no, he's unhappy. What's he on about here? Did I make a mistake? Why don't we take rdata and idata and pass it in as a parameter? rdata array, comma, idata array, and these are going to be doubles, right? Double, and this will be a double. Unexpected ID. There's something about this normalized data which you can't declare it as private. Yeah. So really cryptic data. So this whole cryptic errors here, because I'm trying to just take Java and compile it without actually translating it. So let's go back to the way things were from before. We're globally changing the data through normalization, so that's normalized data. That's fine. So now, it was fine, except you can't declare things as private in C. I guess that's fair. So before I do my PSD computation, I ought to call normalized data, just like the Java program does. Let's just make sure that compiles okay. Thank you. Wow. So you can kind of see why you'd be tempted to just take this whole thing and copy it into Arduino land. And of course in Arduino land you can't do rdata.length and you can't do private void. So it's no wonder that it complains to me, because C just won't tolerate that kind of misuse of keywords. Alright, that's keyword abuse, if nothing else. So now when you call get power spectral density, what's that buy you? It's r squared plus I squared equals PSD of k. So that's what it is. And how does that differ from what I wrote? Well, there's r squared plus I squared, gives me the PSD, and then I print it out, and that's it. So let's see if that works. Well, it's giving me numbers, but I'm not convinced those numbers are correct. What do you suppose is wrong here? Well, the ramp is an integer. I got a feeling that's giving me a hard time. I have a feeling that should be input data. And I have a feeling we should be making a copy of the input data, and it should be into a double precision array. Now if you look at the input data here where this thing is being computed, it's our data. Wait a minute now, that's the inverse DFT. Here it's input data. What are we using for input data? An array of double. That's key. So if you try and do something with input data, I think you're going to have to do something where input data is the same length as the integer ramp. Oh, wait a minute. Double D-O-U-B-L-E, input data array of 8. And I believe that is how we spelt it in the Java program. Yep. So now, when the DFT gets computed, it has to be invoked with a copy of the input data. So here's get ramp data. Here's DFT. The ramp data is coming in as doubles. So I'm thinking this whole thing with the ramp data, even though I started it off as an integer, it really has to be doubles. The input data is going to be doubles. I got ramp data in here now. I think that's going to make a difference. No difference. So there's something else going on here. How about we print out this little section in here? We won't be able to use system.out.println, but maybe we can use serial.println. Serial.print, and we won't be able to use the plus because there is no concatenation of strings like that in C. but we will be able to do serial.print line of, and by using print followed by print line, it'll keep it on the same line, and it'll say equal, and then print line will print the value and then put in a carriage return. So we should be able to see values in here for 2 pi ijk on n. Now, the keyboard shortcut for putting in the serial monitor is Control-Shift-M. So if you do upload and Control-Shift-M, it should show it. Control-Shift-M. There it is. So we are seeing values for 2 pi jk on n. Initially they're coming in at 0. But that's alright, I think. Huh? Yeah. Now I can go to my Java program and I can check it. Is this ramp data the same data that I've had? I think so. It looks very similar. Here's the DFT. Let's forget about the inverse DFT. Actually, you know what I could do is I could just do something like this. Copy. Let's go to my my little main method. Paste. So that's kind of what I was looking for, right? Take the DFT, get the power spectral density, and do a print utils on the power spectral density. What's that buy me? I'd like to try and see if I can get something that's similar to what's in the Java program. You know what I didn't do was normalize the output here. Maybe that would be something that we could try and do, but you can see it's clearly not 0. Right? Clearly not 0. So it's build a ramp, take a DFT, get the power spectral density. When you get the power spectral density, it doesn't look like we're trying to normalize. When you do the DFT, oh yeah, there is a normal density. There is a normalized data. Apparently the DFT returns the PSD. Double PSD array equals, and then just print it. Print the PSD. Yeah, same answer. So that's what we're looking for. How come we're not getting it? Any ideas? Yeah, that's not good, right? Suppose we did something like a debug statement. Serial.print cosine of 2 pi jk on n. There's something about this runtime behavior which is not correct. You think this cosine is right? Look at this number. 0.70. I wonder if I understand how cosine works properly. Hey, is it possible I don't understand cosine and sine inside of the Arduino? I've never used it before. Cosine in the here, cosine in Arduino. You know what we got to do here is we got to write a test program to see if cosine and sine work the way we expect. Because I have a feeling they don't. And that's why we're having this issue. And it's so important that we have sine and cosine working properly. Let's get rid of this print array. Let's write a for loop for double theta equals 0 while theta is less than 2 times pi. Theta equals theta plus 0.1. Okay. Now, how shall we test cosine? How about serial.println, serial.print, quote, theta equals, end quote, n paren sem, serial.println, no, dot print, we'll put in theta, okay, and serial.print, then we'll put in the cosine of theta, space cos of theta equals, end quote, n paren sem. Now serial dot print line cos of theta. I know it's tedious, but I really need to know what theta is and what the cosine of theta is, and I have to prove to myself that the Arduino math package is working the way I expect. And if it's not, I have to deal with that in some reasonable fashion, whatever that may be. Maybe I have to hard code values for cosine of theta and sine of theta in Excel and paste them into an array, which would, you know, make it into a lookup. And that's fine. But if I have to do that, I want to know it. What do you think of this code here? Does that look about right? I trusted cosine and sine to work. Okay, so the cosine of 2 pi is 1. I think that's fair. The cosine of 0 is 1. Right? Goes down. cosine of pi should be -1. So here's -1, and here's something that kind of looks like pi. So I'm convinced sine and cosine are working. They're working just the way I would expect them to work. Is everybody sort of okay with that? The only trouble, maybe a big trouble, is that it's only giving me 2 digits of precision. What's up with that? How come pi was only 3.14? You can set your precision? How do you do that? Oh, you mean set your own version of pi? Alright, so CONST double pi equals 3.1415926 535 8979 323 84 626 433 8327, and it's gonna like it? You think? And I can just write like pi over here, and is there any other place where pi appears? Oh yeah, here, pi. And so now if I do this, it's like gonna like it? Ah, get out. You can check my value of pi in case you think it's not right. But it's right. Oh wow. But look, my cosine of theta is still wrong. I see, I don't feel cosine of theta should give me only 2-digit significant figures. I think cosine of theta should do better than that. Don't you think? I mean, I feel like I'm going to get really different numbers here on in the world of my DFT if I switch from doubles to single precision. I'm not even sure if I have a DFT for single precision, but I could certainly make one. I would not like to, well, let's call it DFT single precision. Okay. And now DFT single precision works with floats instead of doubles. That's fair, right? Why not? Oh, these things are new allocations, R data and I data. But that's all right. Now, I think I did the similar thing. What else? Run. How can he not complain more? Oh, it's still working. I think the PSD should be float, right? And that should be float. And where else is he complaining about? What's he moaning about here? Float. Uh-oh, he's got more moaning. This should be floats. And what else needs to be floats? This has to be a float. Uh-oh, he's got more things that need to be float. That has to be float. That has to be float. That has to be, oh, right. I guess everything else is okay. Nope, he's got more problems. That has to be float. That has to be float. What else? That has to be float. This is no way to run a railroad. This has to be float. Oh, this whole graphing thing is going to be broken now. Who cares? We don't need it. That's why I made a copy. What else? This has to be float. Get frequency. That has to be float. This has to be float. What else? Return frequency, that has to be float. That has to be float. Okay, we're good. Let's run it. That was a little hacky. But you can see I lost a lot of precision by switching to float. But it still works. Right? I mean, it kind of looks like the same numbers, they just don't have as many significant figures. So I'm okay with that. That's what I expected. But this idea that you're going to have double precision entries for cosine and sine, that's just weird. So what else is going wrong here? My cosine and sine are working. Alright, I'm convinced of that. They're just not particularly precise. But other than that, they're fine. What else can we do here that might make this better? We want to print out the array. When you print the array, I mean, the funny thing is we keep specifying everything as being double. Yeah, that ain't right. You think normalized data is messing me up? Oh, wow! I think this is doing an integer division. I'll betcha. I'll betcha. Let's see what happens here. Yep. That's what it was. Normalized data was doing an integer division. So if you put normalized data back in, this here is truncating all the floating point parts out. So what this should do, this is such a wacky thing, is it should say our data equals our data divided by, this should say copy, paste, there should be an equals, this should be divided by, and n is going to have to be promoted to a floating point quantity. So why don't we do something like this? Double little n equals big N, and now when we divide by little n, it'll be a floating point quantity. Because when you divide it by big N, it did a whole number of times into the numerator and came up with 0. Does everybody sort of see that? Does that kind of make sense? I'm thinking that's what happened. Uh-oh. Huh. It's screwed up again. What is wrong with this division? And what if we didn't divide by n? Okay. And then you just ran the whole thing. And look at it. Dividing by n should not make this stuff 0. Unless n is equal to 0. And then there's a problem because you're dividing through by 0. Serial.println n equals n quote n paren sem serial.println quote n. That better not be 0. It's just going to piss me off. N equals 8. 8.0. Okay. Our data equals our data divided by 8. Why is this so hard? That should not turn into 0, right? Our data and I data are doubles, right? Oh no, they're not. There's your problem right there. The data can't be integers, it has to be doubles. That's so key. Man. Oh, I'm such a dolt. I'm sitting here going, why doesn't it multiply? How come I can't divide? What's the matter with me? So apparently I was using an integer array for real and double the whole time. Yeah, that'll do it. This is what I get for trying to program in front of people. No, I'm not usually this dense. Usually. I actually know how to program. Look. It's a discrete Fourier transform and it's running on an Arduino. Ooh, ah, ooh, ah, ooh, ah. Got it? Discrete Fourier transform running on an Arduino. Now, let's compare that with what happens in Java. Alrighty. Now let's take the Java code and compare it with this. Now he says 12 and a quarter, and I got 12 and a quarter. He says 1.707, I got 1.71. He says 0.5, 0.5, 0.298, blah, blah, blah. I got 0.29, 0.25, 0.25, 0.29. It's like the same code. And it's giving me the same answers. And everything. Huh? Huh? Sweet. What's my next step? An inverse discrete Fourier transform. Man, you read my mind. It does? You did it already? Yeah. Oh, crap. You can increase your decimal printout, by the way, in your printout statement, if you put a comma into the number of decimals you want. Oh, really? Yeah. So that's like a feature? In Arduino, yeah. In the Arduino. So if you want to increase that. Oh, I'm in the wrong computer program here. So you're telling me that this print statement needs a comma. How many decimals are we normal to? 6? 7? 6? So you're saying I can just like run this and it'll be good with it and everything? Uploading. Control Shift M. And what do we got? Oh wow. Sweet. I like it. So you had it working all this time while I was struggling? Yeah. Another thing, at the top where you move your arrays. Yeah. So if you want to use n to initiate your arrays, yeah, you have to make it a constant. I don't let you give it time. Alright, so I gotta do constant integer n equals 8. And then I could put n in here, and in there, and in here, and in there. I had a feeling it was possible. I just... Oh, probably need to use capital N. And then I can get rid of this N here. Oh, wait. All the other N's are lowercase. Alright, they better be uppercase N, right? N. I really don't need length anymore, right? I can just say... I might have used it, but it'll complain about it, and then I'll fix it. So now, I think maybe we're ready for a compile check. You can't use length, you gotta use n. Any other problems? Oh, it's good. Let's upload it and try it. DFT's on the Arduino. Sweet. Well, it's about time, damn it. That was hard. Now, did you make a subroutine for this? You did, huh? Oh, that's all right. So, what'd you do? Oh, whoop, 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 whoop. I wish I could figure out a way to keep the scrolling from happening so quick. There's something about if I go in here with my trackpad, click and drag. Yeah, you see it goes very fast. Is that a control panel setup? I'm thinking it is. Right? Isn't there something in here about getting a mouse to track quickly or slowly? So make it slow. Oh, that's for click. Pointer options. Select a pointer speed. Is that what it should be? Apply. See, now it's very slow. Okay. Look how slow that is. That's terrible. Cancel. Alright, so now I've got to go in here and try. See, it's impossible. You can't control this thing. What if I hold the shift key down and drag and then click? Oh, that works. Cut. And so now I can just call DFT. Is that kind of what you did?
Yeah.
Sounds like a plan. Let's go to the bottom here. And we'll do just like you said. Void DFT, put it in the array, and paste. And then that's the end. And is Java going to like that? I mean, Arduino likes that? Oh yeah, he's good with it. And we can run it. And it's a subroutine and everything. Uploading. Control Shift M. And it works still. Well, as long as it still works, I'm good with that. So in a big way, all I need to do is cut and paste the inverse DFT, right? Where's that? So somewhere in here, I should have like an inverse DFT, right? Somewhere. Here it is. Alright, the inverse DFT seems to pass in a well, what's the difference between a DFT and an inverse DFT? It seems to pass this array V. So this is what you did, right?
I just made B global.
Alright, that makes sense. So let's copy it. We'll go into the Arduino code, and then we'll let's see now. Carriage return paste. And now he's going to be unhappy about this being public, and the float cannot be returned, right? You didn't return a float. So then everything is global except for V cannot be local, so that has to be cut from here and brought in as a global variable so that it can be called as a side effect. And I think it's this way, isn't it? Only you need N to be here, and then this part does not get allocated. And I don't think is it supposed to be float? So yeah, make it double. That makes sense. And now if we go back and take a good hard look at this inverse DFT, math.cosine is going to mess you up. So you probably got rid of that. And you probably got rid of this other one. And whoa, this return statement's going to get you in troubles. And what else did you do? Anything else? Oh, math.pi, that's no good. This R length data n, and that's no good. That's global. What else? Pi has to be lowercase. What else? It's looking good, right? So now I have to call inverse DFT and then print out v of k and see if I get back to where I was. So let's go back to our original loop. Let's see, I got a setup in here. I print the PSD. I got to call the inverse DFT, and then I got to call print array of v and see if I can get back to my original data. And let's put in a print statement, serial.println original data extracted or reconstructed data. How's that? Reconstructed, constructed data, and quote and paren sem. And now I do a compilation, and he's unhappy. Did I forget to declare it as returning void? Yep. Well, that happens. Void. Now what's his problem? Too few arguments. Really? Oh. Did I match a parenthesis? The for loops are matched. The inverse DFT is matched. That's likely. Print array of v. Maybe print array doesn't take. Let's just see if it compiles now. He's okay. Oh, right, it needs the size of the array. Bummer. So it's supposed to be 0, 1, 2, 3, 4, 5, 6, 7, and instead I got something which is infinitesimally close to 0, infinitesimally close to 1. My reconstructed data is looking correct. So my DFT and my inverse DFT are working. What do you think of that? It's just as good as Java, and it's working inside of an 8-bit toaster controller. How's that? Good, right? Pretty sweet, I think. Very sweet. So we can assign the FFT for homework, right? Is that a leap? I mean, now that you've seen how the DFT can be ported, I think the FFT it must be cake, because you've now seen the entire thing working, and also we have the example code in Java. It seems like fun, right? DFTs, yeah, no problem, no sweat. Is it break time? Yes, break time. All right, let's take a little break. Let's see, stop.